Okay, so now we are going to talk about parallel line proofs. We've talked about algebraic proofs and a little bit of geometric proofs now. So we're going to continue with geometric proofs, only now we're going to focus specifically on those angle relationships that you learned back in 6.1b. Okay, so those, I'll write them off to the side here. Remember, we have corresponding angles, alternate interior angles, alternate exterior angles, consecutive interior angles, and vertical angles. So here are some of the relationships we learned back in 6.1b. We're going to use these relationships to prove things about parallel lines and transversals. Okay, so our I can statement here is I can complete proofs about parallel lines using properties about lines and angles. Okay, so let's jump right in. Our first one, we are given the information that A, and that's a weird symbol. It looks like ALLB. But if you remember back to 6.1b, okay, this symbol right here means parallel. So what this is saying is we are given that A is parallel to B. That means A and B are parallel lines. And if you don't remember parallel means they never intersect. Okay, so that's what we're given. They want us to prove that angle 3 is congruent, that's that symbol, to angle 6. So my picture to the right here, I'm going to highlight angle 3 and angle 6. Okay, those angles have a relationship already. If you don't remember, those are alternate interior angles. They're sandwiched in between these two lines, and they're on opposite sides of the transversal. This theorem that we are trying to prove for number 1, this is the alternate interior angle theorem. And this theorem says that if your lines are parallel, then alternate interior angles are congruent, which is something that we've said before. Now we're going to prove that it's true. Okay, so just like any other proof, we have 2 columns, statements and reasons. Your first statement is always your given information. So we have A is parallel to B, that's given to us. So now let's look at their statement number 2. Now remember, with geometric proofs, it's not like algebraic proofs. With an algebraic proof, you're doing step by step, and one step leads to the next step. Okay, just like if you were solving an equation. With geometric proofs, 2 statements can give you enough information for the next statement. It's not necessarily one statement always leads to the next. Sometimes you have to gather some information before you make the next statement. Okay, and you'll see that a little bit with this lesson as well. Okay, so let's look at statement number 2. Statement number 2 says the measure of angle 3 plus the measure of angle 4 equals 180. Well, let's look at our picture. If it's not in our given information and they're making a statement like this, let's check and see if the picture tells us more information. Okay, so in this picture, angle 3 is right here, and angle 4 is right here. Now, those 2 angles are right next to each other, so they are adjacent angles, and together they form a straight line. Okay, any angles that are adjacent and form a straight line we call a linear pair. And the reason why I'm going to put this as the reason, linear pair, is because a linear pair adds up to 180 degrees. If you form a straight line, that's a straight angle. A straight angle is 180 degrees. So we are able to say that our reasoning is they are a linear pair, which means they form a straight line. And a straight line is 180 degrees. That's why this reason goes with this statement. Let's look at number 3 now. measure of angle 4 plus the measure of angle 6 equals 180 degrees. Okay, well, 4 and 6, let's see if I can, let me get a different color here. I'll underline these ones. Here's 4 and here's 6. Okay. Do those have a relationship that we know of already? Yeah, those are consecutive interior angles, right? They are on the same side of the transversal in between those two lines. Okay, and we know from another theorem, the consecutive interior angles theorem, okay, that theorem says that if your lines are parallel, then consecutive interior angles add up to 180 degrees. And that's going back to 6.1b. Put that here. Okay. So step number 2 did not necessarily lead us to step number 3. Those are two different things that we had to figure out. But all of the information in 1, 2, and 3, let's see if any of that helps us to get to step number 4. So step number 4 now says the measure of angle 3 plus the measure of angle 4 equals the measure of angle 4 plus the measure of angle 6. So where do we see, I'll highlight here, measure of angle 3 plus the measure of angle 4? That's back up here in step number 2. Okay, and where do we see the measure of angle 4 plus the measure of angle 6? That's in step number 3. Okay, so we're getting step number 4 from 2 and 3. What do 2 and 3 also have in common? Well, they both equal 180 degrees. Okay, so this is going back to a property that you learned when you talked about geometric proofs last time, that if you have two things that equal the same thing, then they must be equal to each other. Okay, I'll write that here. That's the transitive property. Okay, the transitive property says that if A equals B and B equals C, then A equals C. So a good real life example of that is, let's say that myself, Mrs. Smith, is the same height as Mrs. Swenson, and Mrs. Swenson is the same height as Mrs. Sutterfield. Then what does that say about me and Mrs. Sutterfield? It means that we are also the same height. If I'm the same height as Miss Swenson and Miss Swenson is the same height as Miss Sutterfield, then I must be the same height as Miss Sutterfield as well. That's the transitive property. So for step number 4, it's saying that since the measure of angle 3 plus the measure of angle 4 equals 180, and the measure of angle 4 plus the measure of angle 6 equals 180, then they must also equal each other. That's the transitive property. Okay. So now let's look at number 5. Number 5 is similar to number 4. There's just one thing that's missing. Number 5 says the measure of angle 3 equals the measure of angle 6. So the one piece that's missing from 4 to 5 is the measure of angle 4. Okay, so think of this like an equation. How would I get rid of the measure of angle 4 because it's the same on both sides? Normally we would subtract it. If I subtract the measure of angle 4 from both sides, it's going to go away. So I'm just left with the measure of angle 3 equals the measure of angle 6. So how did we get there? We used subtraction. And then the very last statement, angle 3 is now congruent to angle 6. So the difference between 5 and 6 is we're going from equals to congruent. Now, normally this is a step that we would probably do in our heads, but there's a reason why we are able to switch from equals to congruent, right? Normally we just know that they are the same thing, so we just switch them on our own. But when we do a proof, we want to really slow down our brains and really focus on why we're able to do what we do. Okay, so there's a reason why I can change from equals to congruent, and it's a really simple reason. It's just because I know that congruent means equal. So whenever I say it means the same thing, we're using a definition. And this is just the definition of congruent. Okay? Whenever I say they mean the same thing, we're using the definition of that thing. So because congruent means equals, the definition of congruent says that two things that are congruent are equal to each other. So that's why I'm able to switch this congruent symbol and this equal symbol with each other. Okay. So did we prove what they asked us to prove? Well, we stopped here at angle 3 is congruent to angle 6, and that's exactly what they wanted us to prove. So we just proved that if you have two parallel lines, then alternate interior angles must be congruent. That's what we just proved. Let's look at our next one. Number 2, we are given the information that A is parallel to B. So you have two lines that are parallel. They want us to prove that angle 1 and 8 are supplementary. Okay, well, in this picture here, here's angle 1 and here's angle 8. These two angles don't necessarily have a relationship that we name. We don't have a name for those kinds of angles, but we do know some relationships between some of the other angles in this picture, and we're going to use those in this proof. So to start off, our first statement is always our given information. Now the next one, the statement's missing, but it gives us the reason, and our reason is the corresponding angles theorem. What is the corresponding angles theorem? Well, the corresponding angle theorem says that if you have two lines that are parallel, so if A is parallel to B, then corresponding angles are congruent. I'm going to use the symbol congruent there. Okay, so in this picture, where is our only set of corresponding angles? Remember, corresponding angles are angles that are in the exact same position. So if you're thinking of this like intersections, you would have a top left corner, a bottom left corner, top right, and bottom right. The only pair of corresponding angles in this picture is angle 1 and angle 5. Those are in both the top left corner. So this theorem says that because these lines are parallel, which we know that's given to us, those two angles must be congruent. So my statement is that those two angles are congruent. Angle 1 is congruent to, if I can even use that symbol the right way, congruent to angle 5. Okay. Because that's the only pair of corresponding angles up there. So let's now look at number 3. Number 3 says the measure of angle 1 equals the measure of angle 5. So kind of up above in number 1, we have the same situation going on. We're changing between congruent and equals. They mean the same thing. Because they mean the same thing, my reason is the definition. Okay. Now to number 4, angle 5 and angle 8 are supplementary. Okay, well, let's look at angles 5 and 8 here. Use a different color. That's going to be really dark. Let's do orange. Okay, so here's angle 5. Here's angle 8. Okay, because this statement is not given information, I want to look to the picture to see why are they supplementary? How can I say they're supplementary? What reason can I give? The picture tells me the reason. These two angles are right next to each other, which means they are adjacent. And together they form a straight line. Whenever you have adjacent angles that form a straight line, we have a special name for them. We call them a linear pair. Same as we did up above. And remember, a linear pair since it forms a straight line, equals 180 degrees, which also means that they are supplementary. So a linear pair are angles that are supplementary or equal 180. Either way, you could say it. Okay, which takes us to number 5. It says measure of angle 5 plus the measure of angle 8 equals 180. Well, what do we know about angle 5 and 8? They are supplementary. Okay, doesn't supplementary mean that they equal 180? If we're talking about they mean the same thing, remember we're using a definition. Because supplementary means they add up to 180, our reason here is the definition of supplementary. Okay. Which takes me down to statement number 6. Statement 6 says the measure of angle 1 plus the measure of angle 8 equals 180. So the difference between 5 and 6 now is we switched angle 5 with angle 1. Now, what do I know about angles 5 and 1? Well, think back to statement number 3 right here. They are the same, right? They are equal to each other. So because they are the same thing, can't I switch them for each other? Right? That's just like you were plugging something in for x. If x equals 3 in your equation, you can replace x wherever you see it with a 3. The same idea right here. Wherever I see a 5, I can replace it with a 1 because they're the same things. Okay? So that would be substitution. Whenever we're replacing something, we use substitution. Now moving on to our final statement here, we have angle 1 and 8 are supplementary. Well, what do we know about angles 1 and 8? Well, angles 1 and 8 add up to 180. So doesn't that mean the same thing? Supplementary means that they add up to 180. So if they add up to 180, that means they have to be supplementary. If they mean the same thing, we're using a definition. And the definition is of supplementary again. Okay. Notice how these two steps, 4 and 5, go from supplementary to adds up to 180, but 6 and 7 goes from adds up to 180 to supplementary. Okay, the definition of supplementary works both ways. If one means the other, then the other means the one. I know that's kind of confusing, but they mean each other. They can go either direction. Okay. So did we prove what they wanted us to prove? Let's see. They wanted us to prove that angle 1 and 8 are supplementary. So we fulfilled this proof. We finished this proof. Okay. Let's move along. Number 3 is a really short proof. We have the given information that A is parallel to B. They want us to prove that angles 1 and 7 are congruent. So in this picture here, here's angle 1, here's angle 7. These angles have a relationship we know the name of already. These are alternate exterior angles. So this is the alternate exterior angle theorem that we're trying to prove here, which says that if your lines are parallel, alternate exterior angles are congruent. So our first reason is always given. This information is always the given information first. Number 2 says angle 1 is congruent to angle 5. Well, in this picture, here's angle 1, here's angle 5. Do those already have a relationship that we know the name of? Yeah, those are corresponding angles. So this would be corresponding angles theorem, which says that if your lines are parallel, which we know that they are, then corresponding angles are congruent. So that would be our reason for number 2. Now let's look at number 3. Number 3 says angle 5 is congruent to angle 7. I'm going to use a different color here. Here's angle 5, here's angle 7. Do those have a relationship that we already know? Yeah, those are vertical angles. And we know that vertical angles are congruent. So now our very last step, number 4, angle 1 and angle 7 are congruent. Well, if you look up at numbers 2 and 3, we know that angle 1 is congruent to angle 5, and angle 5 is congruent to angle 7. Okay, so angles 1 and 7, let's highlight them, are both congruent to the same thing, right? They both are congruent to angle 5. So what I can do here, since they are congruent to the same thing, they must be congruent to each other. So that was back again to that transitive property. If I'm the same height as Miss Swenson, Miss Swenson's the same height as Miss Sutterfield, then I must be the same height as Miss Sutterfield. If angle 1 is congruent to angle 5 and angle 5 is congruent to angle 7, then angle 1 must be congruent to angle 7. That's it for this proof. Did we prove what we wanted to? Yes. So we're done. So now that we're a little bit more familiar with parallel line proofs, which is what we were just doing, let's talk about how we can prove that lines are parallel instead of be given that lines are parallel. So in all the proofs that we've seen so far, all of our given information was that our lines are parallel. And then we used that to prove other things. Okay, so now we're going to prove that lines are parallel. And in order to do that, we're going to have to learn about converses, not the shoe. Okay, so you can use angle pairs to decide whether two lines are parallel. This is called using the converse. The converse is the opposite of what we've been doing. Okay, so a converse statement pretty much just switches the given and the proven information. Okay, so let's practice writing some converses. Oops. I don't know what's going on. There we go. Okay. So the first statement we say, if it is warm, then the sun is out. So this we call, if you don't remember, is an if-then statement. Okay. An if-then statement, if it is warm, then the sun is out. Well, the converse switches your if and then. Okay. So instead of saying if it is warm, then the sun is out, I'm going to say if the sun is out, then it is warm. And that's the converse. So statement number 2, if the toast is black, then the bread is burnt. Switch those two things around. If the bread is burnt, then the toast is black. Okay. Practice a couple more. If two angles are congruent, then they have the same measure. If two angles have the same measure, then they are congruent. Try number 4 and 5 on your own. See what we can do. Number 4 says, if G and H are parallel, then angle 1 is congruent to angle 3. So the converse, if angle 1 is congruent to angle 3, then G and H, G and H, oh my gosh, I'm not even writing in the right spot, are parallel. That's something that we might prove in this next section. We're proving that lines are parallel. Okay, and then the last one, if P and R are parallel, then angle 2 is congruent to angle 3. Okay, so now I'm switching it, angle 2 is congruent to angle 3. Wow. Guys, if you can't tell, I'm recording this a little late and my brain is starting to go to sleep already. Angle 2 is congruent to angle 3. Then P and R are parallel. That's what that symbol means. So number 4 and 5, you can look up in the picture that's kind of up in the middle of the page. Okay. Number 4, if G and H are parallel, then angle 1 is congruent to angle 3. So if angle 1 is congruent to angle 3, which those are corresponding angles, then those lines will be parallel. So this statement number 4 is the converse to the corresponding angles theorem. And statement number 5 says, if P and R are parallel, then angle 2 is congruent to angle 3. So if angle 2 is congruent to angle 3, then P and R are parallel. Well, angles 2 and 3 are alternate exterior angles. So this would be the converse to the alternate exterior angles theorem. Okay, so whenever we prove lines are parallel, we always are using a converse. So let's do a couple proofs using those converses. Okay, so number 6, it just asks us to state a theorem or postulate that proves A is parallel to B, okay, given that diagram. So what do we know from the diagram? Well, we know that this angle is congruent to this angle. That's what that means with those little arcs in there. Okay, those two angles are congruent. Well, what kind of relationship do these angles have? They are corresponding angles. But our question asks us to state a theorem or postulate that proves that two lines are parallel. Whenever we're proving lines are parallel, we use a converse. So that means that this answer for this problem would have the converse of, and then what kind of angles do we have? Corresponding angles. So this would be the converse of the corresponding angles theorem. Which would say if two corresponding angles are congruent, then the lines must be parallel. Okay. Actually, let's see. I'll write that here. Okay. So if corresponding angles are congruent, then A is parallel to B. That's what that theorem would say. The converse would say that. Okay. Let's do an actual proof now. So number 7, it says prove the converse of the alternate interior angles theorem. So if we're proving a converse, that means we're proving that lines are parallel. right? We want to prove that these two lines are parallel, and they are giving us the information that angles 4 and 6 are congruent. Well, angles 4 and 6, we know, are alternate interior angles. So we're going to use that to help us prove this. Okay, so first reason is always the given information. Okay, statement number 2, angles 2 and 4 are congruent. Well, if I go to my picture here, here's angle 2 and here's angle 4. What kind of relationship do they have? Well, they're vertical angles. Vertical angles. And we know that vertical angles are congruent. So angles 2 and 4 must be congruent. Let's look at number 3. Angles 2 and 6 are now congruent. Okay. Well, what do I know about angle 2? We know that it's congruent to angle 4. And what do I know about angle 6? It's also congruent to angle 4. So angles 2 and 6 are both congruent to angle 4. So if they are congruent to the same thing, then they must be congruent to each other. And that is that transitive property again. Okay. So now we're jumping from the fact that angles 2 and 6 are congruent to that those two lines are parallel. So let's look at our picture, because that doesn't give me a whole lot to work with, right? I'm going to use a different color. So what do I know about angles 2 and 6? What kind of angles are they? They're corresponding angles, right? So I know that these two angles are congruent because it says so in statement number 3. I know that these are corresponding angles. So if corresponding angles are congruent, then what do we know is true? Well, if you look back up at in problem number 6, the converse of that theorem says if corresponding angles are congruent, then A and B are parallel. So because I am trying to prove that these two lines are parallel, I know I'm going to use a converse here. Whenever your last line is parallel lines like this, you're always going to be using a converse of a theorem. So what converse do we use? Well, what kind of angles did we see in the statement right above? We saw corresponding angles. So the corresponding angles theorem, or the converse, tells us that those lines have to be parallel, which is exactly what they wanted us to prove. Okay. So let's do, I think this is last one. Number 8, we want to prove the converse of the consecutive interior angles theorem. So we're proving a converse, which means we are proving that lines are parallel. And the information we're given is that angles 3 plus angle 6 equals 180. So in my picture there, let's highlight 3 and 6. And those are consecutive interior angles. So now we're saying that if these two are are supplementary, then our lines must be parallel. So first one already done for us because it's always the same, right? Our given information. Oops. Now statement number 2 says that the measure of angle 6 plus the measure of angle 7 equals 180. So I'm going to highlight 6 and 7 in my picture here. Here's 6, here's 7. What do we know about those two angles? They're right next to each other, so they're adjacent. And together they form a straight line. So what do we call those kinds of angles? They are linear pairs. Okay. So these are linear pairs, which means that they add up to 180, which is exactly what this statement is. So now we're jumping to number 3. That says the measure of angle 3 equals the measure of angle 7. So that's kind of a big jump. We have angle 3 plus 6 equals 180, and 6 plus 7 equals 180. So how am I able to jump to 3 must be equal to 7? Okay, well, I'm going to do a little bit of equation work on the side here. Let's say that angle 3 is x and angle 6 is y. Or even better, let's say that angle 6 we actually know is 70. Okay? We don't know what angle 3 is, but let's say angle 6 is 70, and these two add up to 180. That's this first statement. Second statement says that 70 plus some other angle, 7, also equals 180. My goodness. Well, if I get x by itself in this first equation, x would have to be 110. And if I get y by itself in this equation, y would have to be 110, which means that x and y are equal to each other. Okay? So that's what's happening here is these two angles, angles 3 and 7, share a supplementary angle. This supplementary angle is, in my example, 70, but in the problem, it's angle 6. Okay, so my reason here, it's a little bit long, so give yourself a little bit of room. If two angles share a supplement, which means an angle that makes them supplementary, then they are congruent. And my proof is right there, that work right there. Okay. So that one's kind of a big jump. Hopefully we understand why that works. Now let's go to number 4. Now it says the angle 3 equals angle 1. Well, how are we able to switch angle 7 to angle 1? Okay. So if I look at my picture here, I'm going to erase some of the highlighting in here. Here is angle 7, and here is angle 1. What do I know about these two angles? They have a relationship. They are alternate exterior angles. So how do I know that they're congruent? Well, alternate exterior angles theorem, I don't know what I'm doing, you guys. I'm jumping way far ahead here. Angle 3 and angle 1, I'm one step ahead. I'm sorry. Angle 3 and 1, that's what we're looking at, not 7 and 1. Angles 3 and 1, what do we know about those angles? They are vertical angles. That is my reason. I'm sorry. They are vertical angles. That's why I know that those two angles are the same. Now we're looking at 1 and 7. So I know that the measure of angle 1 equals the measure of angle 7. I don't even need to use alternate exterior angles, even though I know that that's what they are in the picture. I can use these two steps here to get me to number 5. Okay, angle 3 equals the measure of angle 7, and angle 3 equals the measure of angle 1. So since the measure of angle 7 and the measure of angle 1 equal the same thing, doesn't that mean they equal each other? That's a property we've been using a lot now lately. That's that transitive property. They both equal the same thing, so that means that they have to equal each other. And now from 5 to 6, the only thing that's changing is we're going from equals to congruent, which we know that they mean the same thing. When they mean the same thing, we're using a definition. And the definition is of congruent. So our very last step, we're going from angles 1 and 7 are congruent to say that L is parallel to M. Well, we've already said what angles 1 and 7 are. They have a special relationship, right? They are alternate exterior angles. Since I'm proving, and remember this is always true, whenever you're proving lines are parallel, your last reason is always going to be a converse. To figure out which one I put here, look at what kind of angles you had right above. These angles are alternate exterior angles. So my converse is the alternate exterior angles theorem, which says that if alternate exterior angles are congruent, then two lines are parallel. And we proved what they wanted us to prove. Okay, so now we know that those lines are parallel. So these geometric proofs can be kind of tricky. Hopefully you guys are following along, and if you're not, please do not hesitate to ask your teacher for help. Okay, we are happy to help you with these. This is really tricky stuff. Okay, but now we're going to move on from proofs for a little bit and talk about triangles. So the next section gets a little bit easier because we're taking a break from proofs.